Hey everyone, welcome back to AP Precalc. This is lesson 3.7. Let's get right into it. All right, so pause the video if you haven't done so yet because I am about to go over the bell ringer. So here we're given 5 points. We're given F is 2, 30, G is 6, 20, J is 10, 10, K is 14, 20, and then P is 18, 30. And now we want to find the values for A, B, C, and D, where this is going to be modeling not a cosine, but a sine equation. So taking a look here, the first thing I always look for is my y values. I see I have a maximum of 30 up top. I have a minimum of 10 and a midline of 20. So I'm going to label those three right there. And with this, we can find A and D pretty easily. D is going to let's start with D. So that's going to be our midline, the number that comes in the middle, which is a y value of 20. And then A is going to be our amplitude, and that's the distance from our midline to our maximum or the distance from our midline to our minimum. Either way, because the midline is in the middle, the distance should be the same, so it should be 10. That's going to be our A value. Now, if you wanted to and wanted an extra challenge, you can make the A value negative. However, it's always easier when we have an option to just make A positive and keep it positive. All right, B and C are going to be focused now on our X coordinates. So B is our B value. So remember our B value is going to be 2 pi over our period. Once we have that, our period starts at F and ends at P. This is the length of one full period because it goes down and then back up, and then that same pattern repeats itself. So when it starts at 2 and ends at 18, the period is going to be 16 16 units long, and so that's our period. So our B value should be 2 pi over 16, which will simplify to pi over 8. That is going to be our value for B in this case as well. So pi over 8. Now our C value, because we chose a positive amplitude, is just going to be our sine starting point, but then the opposite x coordinate. So here, if remember, our sine starting point is going to be at the midline going up. That is going to be our sine starting point because that's where we typically would start the parent function for sine. Looking at that, let me use blue here. Our sine starting point is actually going to be point K, not G. So make sure that you get the sine starting point will always be K for any of these questions. Now look at the x coordinate is 14. However, for our actual answer, C should be the opposite, negative 14, and that is going to be our solution there. Right, so you will see one of these questions, two of these questions, honestly, on your next test, so just be prepared for that. All right, so previously we've taken a look at sinusoidal functions and how they can be written in the form of like y equals a sine and then b x plus c plus d, or with theta and f of theta. Or you've seen the same thing with cosine as well. That's been another function we've looked at, but it's just this general equation. Now we're going to take a look at these equations and answer different questions about them. So while today we're not really learning that many new things or like a whole new concept, we're going to be learning how to apply what we know in terms of identifying A, B, C, and D into more complicated problems. So the first concept, this is new, is going to be frequency. Very rare that you will see this, but you could come across this as a multiple choice question. The frequency of a function is the reciprocal of the period. So don't get this confused with your b value, right? Your b value is something different than your frequency. For example, the frequency of just y equals sine x, right, is 1 over 2 pi, because the period of this is just our parent function, is going to be 2 pi, technically over 1. So then the reciprocal of 2 pi, or our frequency, is going to be 1 over 2 pi. You're going to flip that fraction. Right? So find the frequency of the following functions. Here, you first want to start by finding the period, and then take that period as a fraction and just flip it. So here, with our b value, being 4, our period is going to be 2 pi over our b value can also give us a period. So 2 pi over 4, which is pi over 2. And I'm going to go over this in class as well, but the reason why we can do that is if you have just kind of taking a separate break from that, if you have fractions a over b equals c, then you can switch the denominator and the other side and say for a fact a over c is equal to b. That's kind of like what we're doing here. When you have 2 pi over the period equals your b value, we can switch those two and do 2 pi over your b value equals your period. So that is important to know. However, we're not done yet. Because our period is pi over 2, our frequency of f is going to be 2 over pi. So that should be our answer there. Taking a look at this one, our b value is going to be 2 pi. So then our period should be 2 pi over our b value. This is just 1, which means our frequency is equal to 1 as well. And then finally here, our b value is 4 pi over 3. So then our period is going to be 2 pi over that, which is 2 pi over 1 times keep change flip, 3 over 4 pi. Those cancel out. That cancels out. And we have 3 over 2 as what we're left with as our period, which means our frequency is going to be the reciprocal, 2/3 there. All right, example number 2. The graph above shows, or the figure above shows a graph of a periodic function f. What is the frequency? So first let's find the period, right? We see it's kind of like more of a sine function, right? Because it starts at the midline going up. So it goes up, down, then comes back up. And this all takes place from here to here. Now from here to here, this unit or distance is 1, and this is half of that in terms of just the number of squares. So this is 1/2. So that's going to be our period. So we know the period is equal to 1/2. So then our frequency is going to be the reciprocal of that, 2 over 1, or just 2. So B should be the correct answer for example number 2. All right, concept number 2 is using maximums and minimums to our advantage. The smallest interval over which the maximum or minimum output or y values start to repeat can be used to determine a period for a sinusoidal model. We kind of already know that, right? When we were looking at that bell ringer today and we wanted to figure out how long was our period, we looked at F, G, J, K to P. Like, what is the distance from point F to P, which is the distance from maximum to maximum? So when you see a maximum and then it repeats itself, that's the length of one period. So we kind of already know this. It's just looking at more questions and more trig functions in depth. So here, let f be a sinusoidal function. What is the period of f? Here we could look at maximums. So right here, and then right there. You could also look at the distance between minimums. Because of the way this is graphed, this is going to fall in between 0 and 1, so this is going to be 1/2. However, if we didn't even know that, right, let's say we can't make that assumption. We can also look at midline values, right? So here, you start at the midline and go up, down, and then back up. And then you do the same thing again here. So you start at -2, and then you end it at 0. So this distance is 2. That is our period. So B is the correct answer for example number 3. All right, concept number 3, more maxes and mins. The maximums and minimums can be used to determine the amplitude and midline or vertical shift for a sinusoidal model. Basically, if you know your max and you know your min, you can find halfway in between them to get your midline, right? That's also your vertical shift, which is your D value. And then with that, you know the distance between your max and your D value is going to be your A value, your amplitude, if you have to find what A is. All right, so example 4, a clock is mounted at the wall and point P is located at the tip of the minute hand of the clock. Here we know it's going to be represented with a sinusoidal function where we're looking at how tall or far away is point P from the ground. So at time t equals 0, point P is 70 units away from the ground. So when P is pointed up at 0, this distance is 70 units. However, when P is pointed at 30, right there, that's going to be point P, this distance is only 52. And this represents a maximum, so the furthest possible away it can be from the ground, and a minimum, the closest that minute hand can get to the ground. What are the values for A and D? Our amplitude and kind of our midline in this case. So taking a look at our maximum and minimum, we have 70, so 70 there, and then 52 as our max and our min. So first thing I want to do is try to find a midline, right? What is our middle number between the two? So we can always figure this out using good old algebra by just taking the average of those two numbers. So 70 plus 52 divided by 2. This is 122 over 2, which is 61. So 61 should be our midline. That's going to be our D value. So D equals 61 for sure. Now our amplitude is going to be the distance from either 52 to 61 or the distance from 70 to 61. 70 minus 61 is fairly easy to do in your head. That's 9. That should be our A value. So here we have A is 9 and D is 61 in this case. Example 5, the figure shows a graph of sinusoidal function h. What is the period and amplitude? So taking a look here, you can kind of sketch your midline fairly easily, which just so happens to be the x-axis. Looking at that, our amplitude is going to be the distance from our maximum to our midline. That's going to be 3 units tall, so our amplitude should be 3. So we can eliminate B and D. Now, what is our period? Well, let's take a look. I like to go to see if we can find max to max, which goes from 1 to 5. So the distance between 1 and 5 is going to be 4 units. So that is going to be our period. C, our period is 4, and our amplitude is 3 in this case. All right, so concept number 4 is just using coordinates to determine basically your sine or cosine starting point for a sinusoidal model. So remember, the main thing here is just remembering cosine starts at a maximum and goes down, right? That's going to be a cosine graph. And a sine starting point starts at the minimum or midline and goes up. So that's going to be part of a sine starting point there, where it starts at the midline and goes up like that. So example 6, let g be a sinusoidal function where cosine equals 2 parentheses x plus c minus 1. The function g, what could represent the constant c? So here, the main thing that we want to see is what phase shift do we need to do in this case, right? And so we're looking at how far do we move the graph left or right to align with a cosine starting point. And so a cosine starting point is, remember, at the maximum going down. So we're going to test all 4 of these options to see if we will get any of them to align with a maximum going down. So looking at 0, right? If there's no phase shift on the graph, that would fall right here. That's where x is 0. That is at the minimum going up. That's not what we want. So A is not the correct answer. B, positive pi over 4. That's moving it pi over 4 units to the right, or to the left. Sorry, if it's plus pi over 4. So this happens to be smack dab in between negative pi over 2 and 0 would be negative pi over 4. That's where it would start, which is at the midline going down. That doesn't even come close to being a maximum, so we're going to eliminate B. C is positive pi over 2. So this is moving pi over 2 units to the left. That's going to be right here. And here we are at a maximum and we are going down. So this one absolutely works. C is the correct answer. But looking at D, here we have pi. And so that's going to be moving pi units over to the left and then moving down in this case because that's where the graph is, or hits x equals negative pi. And this is at the minimum going up, which wouldn't necessarily be this cosine function here with no amplitude. And so we can rule out D, marking C as the only correct answer there. Technically, if they had negative pi over 2 as like an additional option, this would also be correct. All right, example 7. The figure shows a graph of trig function p. Which of the following could be an expression? So here, let's take a look at what we know. Well, we know the midline is probably going to be -1 graphically. And then we know our amplitude is going to be, here the total width or height of the graph, sorry, is going to be 6, which means our amplitude should be 3. But we could see negative amplitudes, like negative a values, because a value is not your amplitude. Our amplitude is going to be 3, but our a value could be 3 or -3. So be cautious of that. Because the midlines are all 1, that's kind of irrelevant. So let's look at the starting points and almost start the graph of each function and see which one actually aligns on the graph of p above. So here we have x minus pi, and it's a negative cosine starting point. So remember, x minus pi means we're moving pi units over to the right, and then a negative cosine means you start at the minimum and you go up. That is not aligning with the graph, so we can eliminate A. For B, x minus 2 pi, that's moving 2 pi over to the right, and because it's a negative cosine, you're starting at the minimum, and you're going up this time. This does align, so B is the correct answer. Testing the other two, C, 3 times sine negative 3 pi over 2 minus 1. So negative 3 pi over 2 is going to be right here. And then negative sign is going to be at the midline going down. But this is a positive sign, so this would be at the midline going up. So here, remember, this is the only one that's positive, so C is not the correct answer. So we are going to eliminate C from our option bank as well. And then we have one more just to guess and check. We have sine x minus pi over 2, which means we're going pi over 2 over. We're going to start the midline, but then because it's negative sign, we're going down. So it's going to be like that. That also does not align with the graph, so we can rule out D, making B the best answer possible there. You will see one of these on your test for sure, so just be on the lookout for that. All right, concept number 5, solving complicated problems. We can use actually what we know without even using Desmos to solve complicated problems that we may not have been able to otherwise, just by looking at general trends on where does cosine start, which is at the minimum going down, where does sine start at the maximum going up, and so on and so forth. All right, so let's try example 8. Here we have the average monthly temperature in degrees Fahrenheit for a town in Indiana can be modeled by the sinusoidal function from 1 to 12 months. Based on the model, which of the following is true? So taking a look, let's work through our answer choices and eliminate the ones that we know are wrong. The maximum average monthly temperature is 60 degrees Fahrenheit. So is this the maximum? So we see we have a D value of 60, right? That's going to be our midline, is 60. And then we have an amplitude of 20, which means our maximum should be, in this case, 80, and our minimum should be 40, both being 20 units away from the midline. So here we know our maximum is not going to be 60, so A is incorrect. We also see that it is a sine function, right? There is a B value, right? So that's going to alter how long it takes for the period, but there is no phase shift. There's no C value, which means it's going to be a regular sine starting point. So that means at 0, we are actually going to start the midline and go up. Knowing just that and sketching that rough graph, which is what I would always recommend for these story problems, is enough to be able to answer this question, right? Because B, the maximum average monthly temperature occurs at 0. That's false because at 0, we're at the midline. We're not at the maximum. So B is incorrect. C, the minimum average monthly temperature is 40. That is true, right? The minimum is 40 in this case. So C is our correct answer. And then D, the minimum occurs at 0. No, the midline or the middle value occurs at 0, not the maximum or minimum. So C would be the correct answer here. All right, number 9, very similar, and you will see one of these on your test as well. The population of trout in a pond can be modeled by F based on the following, or based on the model, which of the following is true. So here, let's sketch a rough graph. Right, so whoops, let me sketch a new one. Here we have our maximum, our midline, and then another minimum value. Here, our midline is actually presented first, but that's okay. So 3,400 should be our midline, but then our amplitude is going to be 1,500. So doing 3,400 plus 1,500, you should get 4,900. That's going to be our maximum value. Our minimum value is going to be 3,400 minus 1,500, which 34 minus 15 is 19. So here you should get 1,900 as your minimum. Now let's take a look. We know it's a cosine graph, right? There's no phase shift, which means we're starting at the maximum and then going down, coming back up, and that's what it's going to look like. Based on the following, which of the model is true? The maximum occurs at 3,400 trout. That's not true. It occurs at 4,900. B, the maximum number of trout occurs at t equals 0 years. That is true, right? Because it's a cosine graph with no translation. So B is our correct answer. Taking a look at C and D, the minimum number is 1,500. That's not true. That's the jump. And then the distance is, or the minimum number of trout occurs at 0. No, it is the maximum in this case. So C and D are out, and B is the correct answer there. All right, concept number 6, setting up a sinusoidal function. So without our calculator, we can actually set up sinusoidal functions to solve story problems. All right, so for example number 10, here we have a yo-yo on a 30-inch long string. At 0, the yo-yo begins to rotate, and then at 5 seconds, it has completed 20 rotations and ends up at the same position as it started in, so it's just 20 complete and full rotations. A sinusoidal function is used to model the x-coordinate. Which of the following is an appropriate model? So taking a look here, I see the only thing that changes from these 4 answers is our b value. So I really want to find what is the correct b value. And so looking for our period, the biggest indicator is at t equals 5 seconds, the yo-yo has completed 20 full rotations. So I now know 20 rotations can be done in 5 seconds. Here, I want to find the length of the period, which is how long does it take to complete one rotation. So here, you're just going to divide both sides by 20. 5 over 20 is 1 over 4 seconds. So one rotation is going to be 1/4 of a second. Knowing then our period should be equal to 1/4. With our period being 1/4, our b value is going to be 2 pi over 1/4, which is 2 pi times 4 over 1, which is 8 pi. So D is going to be our answer here. In this case, though, this is also true because we are starting in the middle at 0, and we're looking at the x-coordinate, right? Well, the x-coordinate is going to go up until it hits this point. Then it's going to move back to the left and go down, down some more, hit this point, and then keep on moving up. So this is going to be go up, down, down, up, right? This is very much so the parent function of sine of x. We can also use regression in Desmos to find the best sinusoidal model by adding a table and then adding our x and y coordinates. You'll never need to do this on the graphing calculator part of the short answer section, but you may be asked to find one or two sinusoidal models using Desmos in the multiple choice section. So it's pretty easy. It's what we've always done. First, you're going to add a table in the top left corner. And then you're going to choose sinusoidal option or regression from the drop down. It is the very last option, so just be aware of that. So we'll try example 11. Here, the function n gives the number of nighttime hours of the first day on a given month. What is the maximum number here? So taking a look here, we have 5, 8, 11, and 12 as our option choices. In Desmos, I would plug in all your numbers. I know it's tedious. And then do sinusoidal regression. Here, this is our predicted maximum. And so we see our predicted maximum is at 11.33285. And so in this case, that is going to be our correct answer. This is going to round to 11 there. All right, so example number 12, we're given a bunch of temperatures, and then we want to find, with a sinusoidal model, what was the average temperature at time t equals 6. So looking at this, we're going to plug in the table in Desmos, like so, pick sinusoidal regression, then I copy and paste this regression into the next row. I replace y with f of x, so replace y with f of x. That way we have something to plug in. It's pretty much the same. And now I want to plug 6 into the equation. So that's going to be f of 6. And this should give us our answer, 81.339. So I'm just going to say 81 should be my answer for this one here. All right, concept number 8, just graphing sine and cosine. You could also use Desmos to graph sine and cosine, and then figure out information about their midline, their amplitude, their max, min, period, everything like that. So let's work through a few of these problems. Here, consider those two functions. What are the two zeros defined by these two functions added together? So this is a composition function. The way we're going to do it is in row 1, row 2, and then row 3, it literally is as simple as if you type in f of x equals 2 cosine x plus 1.78, and then in row 2 you type g of x equals sine x plus 0.55. That will graph two separate functions. Those are not our answer, but we want to look at h of x equals f of x plus g of x, and then we're only going to look between 0 and 2 pi. So doing that should look like this. Here we have f of x and g of x. I also clicked this button here so we don't show them. H of x is the composite function. That is shown on the graph. And then from 0 to 2 pi, I have it kind of shaded. And then I just highlighted the two zeros of the graph. So that should be our answer, 0.097, rounding to 3 decimal places, and 3.239. Yeah, so those should be our two answers there. 239, yeah, 9. Right? All right, so for example 14 here, taking a look, we have a sinusoidal function, 2 cosine, and then sine parentheses x plus 3 minus 2, all on the inside of the cosine function there. What is the amplitude of f? So here I would just start by graphing it in Desmos. It should look a little something like this, so look a little weird, but it should still behave sinusoidally. It's such a weird word to say. Once we have this equation graphed, to find the amplitude, remember just take the minimum and the maximum and then find the middle number and the distance between them. So here we're going to take our y values. We have 1.0806 as our maximum, and then we have negative 1.97998 as our minimum. We want to find the distance between the two. So we're going to do the max minus and then the min. And remember to keep that negative sign. Very important there. So we should get a number that's bigger than both of those, 3.06058 or 3.06 if you were rounding one. But I would say stay away from rounding until you get your final answer in problems like these. Once we have that, that's going to be the distance from the max to the min. And then to find our amplitude, we're just going to cut that in half. So we're going to take that number with all the decimal places and divide it by 2 to get our answer 1.53029, which should be A as our correct answer there. Example number 15, the rate at which water is being pumped from a well is given to us in liters per hour and given to us by the function r, where it's kind of a mix of multiplication and a sinusoidal because I see a cosine in there. What is the absolute maximum that water is being pumped from 0 to 24? So here I'm going to graph this function and then just look for the highest y value. So remember, whenever they ask about maximum or minimum, an absolute maximum or minimum, they're talking about y values here. Taking a look, we have this function graphed here. I would say the biggest thing is just type it exactly how you see it in the question. There's not going to be any deviations. The only difference I did was I just replaced t with the variable x because x is what Desmos will recognize. They will not recognize the variable t. Right? So you should get a weird looking function. And here we're only looking from 0 to 24. So this is very important as well because there's technically higher points, outside of that, but we don't care. We're only looking in between those two lines. And then the highest point is going to be right here. So I hovered over it and clicked the point. And then we are only looking at the y value. So our answer should be 35.061, or B as the correct answer for example number 15. These two you would definitely get with a calculator for sure. So you won't see any on your test because your test will be no calculator, but you will have some more in your homework. All right, and then this is a past AP exam question from last year's international exam. This is a no calculator question, so this is one that you should be able to solve without a calculator. And so taking a look here, the population of rabbits is modeled by this function from 0 to 15. Based on this model, what is the first time the population equals 400? So what I would try to do is I would sketch a rough graph, right? We know our midline is going to be at 500 and our amplitude is 100. So let me sketch that out now. So here, we know our midline is at 500, our amplitude's at 100, so I know it's going to go 100 up and 100 down. So 6 and 400 should be our max and min respectively. Knowing this, when's the first time that this equals 400? That's going to be when is the first time we're going to hit our minimum. I also see that there's no phase shift, which is nice. So at 0, because it's a cosine function, it's going to start at the maximum and then go down and come back up and continue on like this. Now we do have a b value. Our b value is going to be pi over 3, which means our period is going to be 2 pi over our b value, which is 2 pi over 1 times 3 over pi. This will cancel out. And so our period is just going to be 6, right? So this should be 6. So from 0 to 6, let me put the 6 down here. From 0 to 6, we're going to start at the top. We're going to go all the way down and then come back up. But we're looking for what is the x value, what time is this going to first hit 400, which is going to be halfway in between the two maximums. So here, this should be 3. And so that is going to be our answer. Time t equals 3 there. Right? So that's an example of the level of difficulty you should expect with these AP questions. The AP questions are very difficult. But that's why the exam is curved, where you only have to score. If you score 50% or higher on every single question, you'll get at least a 4. If you score 30, I want to say 33 or 34% higher, or like of all the questions, you'll get at least a 3. So you have to miss a lot for you to not pass. So this is the level of difficulty that I would expect on the AP exam. All right, if you have any questions, please come see me during office hours. I will talk to you guys later. Bye.